Hello, everybody. Welcome back to week 3 of IS4302. I'm glad to see that we're all still making it. Hopefully, your classmates are going to come on time and not interrupt the lecture. Well, we'll get started right away. Of course, we are doing some recordings of the lectures, but to get full participation, it helps to be in class. So I'll try to give some more opportunities for participation for those who took the efforts to get out of bed and come today. So today we're going to be covering, again, quite a bit of content. That's why we're, again, trying to start on time as much as possible. We're going to be going through both a conceptual piece and introducing you to the coding side of this class. And then after lecture, we'll be releasing a lab that you can do to start to get used to coding smart contracts. And then, of course, similar to last week, we're going to be going through every weekend doing a post-class memo. It's going to be shorter than last week's, but just as a way for you to kind of cement your review of the information and give partially to give feedback back, but partially to help extend anything that you found to be particularly interesting or to have any doubts about. Unfortunately, for this past week's feedback, I haven't compiled the questions into a Q&A to include into our lecture. And given the compressed nature of the lectures generally, I might save that to do asynchronously. So if you have put any questions that I haven't got to into the lecture, into your last week's post-class feedback or survey, I'll be, after class, putting some Q&A basically onto the discussion board on Canvas, so that any doubts that are kind of arose during your last couple weeks content, I'll be addressing there. So thank you all for kind of doing your best effort to put any information there as well. So today, I guess also one final thing about participation, I'll be noting down your names and also keeping kind of syncing it right after class onto my spreadsheet. If you guys have any doubts that I remembered, you feel free to talk to me in person, or if I spell your name correctly. I think generally I'm doing all right, but again, people, I always welcome a chance to talk to me face to face, and I might open an option in the surveys later on to just indicate on there as well, if you want me to double check if you're worried about that. Anyways, moving forward, today we'll go through a little bit of more discussion of smart contracts, this idea of tokenization, and NFTs, probably all words that you've heard before. And then again, we'll go into some what are called standards in Ethereum that will show how to implement this in real life. So smart contracts are basically expressed as this idea of contracts or pieces of code that are designed to carry out a set of instructions. They were, I'll just go through the slides and then kind of do a little commentary. There's no middleman. So in a traditional contract sense, if there's a dispute between you and, let's say, your landlord, then you could go to the court, and the court will arbitrate who is in the wrong and make sure that the contract is upheld to the best of your ability. With a smart contract, there's no intermediary, there's no company that's holding information or verifying it. Everything is going to be run on the blockchain. All the information that needs to be checked is going to be checked on the blockchain and executed automatically like any other piece of code. This concept of decentralized applications, or dApps, the capitalization is not super consistent, so you'll see throughout the slides it might be a little bit different from here. But in general, the idea of decentralized applications are going to be consist of services that are that consist of a series of linked smart contracts. So when you think of a smart contract, if you've done object-oriented programming, you know that for any kind of big program, you'll have several pieces of several different files that, of course, are all going to be interacting with each other. So each file, in this case, is going to be pretty much what a smart contract is. This idea of calling it a contract in the first place as opposed to something else was a little bit of a marketing move by the people at Ethereum to kind of clearly suggest the idea that this is going to be dealing with money, that once certain conditions are met, certain actions are going to be taken automatically. And so this idea of contracts is not something that you need to know a lot about the law to understand. It's pretty much more of a marketing point of view, just to describe a piece of software that runs in a decentralized manner. That in general, you do need some currency to interact with to get it to trigger, but we'll discuss that kind of going forward. So how do smart contracts work? If you imagine a conventional online transaction, you'll typically, without a smart contract, let's say buying a car online, you'll need several pieces of information. You'll need a listing site that holds all the information of the cars you might like to see. You need a way of communicating with the sellers if you want to buy one of the particular cars. You'll need a payment system like Stripe or PayPal or something like that, or a credit card system that allows you to exchange money once you found a car that you want. You need some capacity to get a refund if the car turns out to be a dud or the person doesn't deliver the car. And you'll need some way to register a change of the car ownership with the authorities. So if somebody sells you a stolen car, you want to make sure that it's not stolen, and that if you have to pay taxes on the car or have some kind of proof that you're allowed to drive it, you want to register that with authorities. So these are all pieces of information you might kind of consider happening in a typical online marketplace, or at least in this case for a car. Each of these components requires a level of trust between you and the service in question. So in addition, each of these processes is typically controlled by a different company or individual. So again, if you're doing payments, it might be going through PayPal, it might be going through MasterCard, it might be going through some other Stripe or some other service, rather than the company itself. And this wouldn't take necessarily that much for a sneaky person or organization to meddle with any of the above elements, which could spoil or void the whole process. So if you have a communication application that's a service built into the software, if somebody was to hack that, then they could potentially start diverting funds or kind of abusing the trust of the people who are using the platform. So there's all these different things that are built into a typical platform that prevent potentially a few points of weakness, that you have to trust each of the pieces along the way. So sorry about some of these kind of emojis not showing up, but in general, how smart contracts work is that they try to allow you to do these things, or we create services that allow you to potentially do these things in ways that are not going to necessitate trusting particular companies at any step along the way. So of course, we talk about security, where they use cryptography to prevent the alteration of records. So there's immutability once it's in the system. There's verifiability that only people with a certain key, the private key, are allowed to access certain information or input certain information. There's just often a level of transparency where everyone can see what this was in the smart contract. So it's like open source. Everybody can see what the code, what the business process is going to do once you execute it and what it's being used for. I'll make a note about transparency that will come back in a future week. Just because we say things are transparent on the blockchain or that has certain features of transparency, we actually, in many cases in applications, you want some degree of privacy as well. And this is something that is easily built into any decentralized application. So for example, if you don't want your home address to be listed in the website, but it's still somehow stored in an encrypted manner, that's something that decentralized applications are still able to do. So there's a level of transparency that's of data that is customizable by the programmer. But once you put the program up there, everybody can see what it's supposed to do, and it's not going to route information or money into strange areas. In terms of being third-party free, smart contracts don't need middlemen to verify them unnecessarily. The blockchain does that for you. In terms of the truthfulness of the kind of ability for somebody to process a transaction, you do in fact have people who will check that the smart contracts themselves don't have bugs, and these are services that auditors will kind of potentially charge money for, or people in out of the goodness of their heart or self-interest will kind of in a crowdsourced way verify that certain smart contracts are trustworthy. And so this is something that if enough people are kind of telling you, yeah, this is probably a smart contract that's not going to have a bug in it, you can generally trust it. Smart contracts tend to be autonomous, so they work automatically. There's no need to wait for human intervention. So if this car purchase system was supposed to, any of the steps along the way here, of course, somebody could have an email sitting in their inbox they're not getting to and you're waiting around for something to happen. Smart contracts should just work automatically and kind of automate the business processes. And generally, they should be accurate. So it's because they're written in code and they have fewer areas where there's humans in the loop, there's fewer opportunities for people just to make mistakes if you're automating as much of the process as possible. Smart contracts also automatically again execute when predefined conditions are met. This is kind of the idea behind them. And the operation within them has certain main features associated with it. So interconnectivity, such that they possess a limited range of functions. And by kind of connecting to many different contracts, more complex structures called these decentralized applications can be created. And if you think all the way back to our first week where we showed this giant cloud of different kinds of applications, going from layer 1 to capacity layers, to identity, to verifiability, to all these different sub-services, payments, and all these different things. By being able to, decentralized data storage, by being able to create different software as a service, your own application can kind of draw on some of the other applications in the ecosystem that are themselves built on smart contracts or built in a decentralized way. So by having this kind of interoperability or interconnectivity, not only can you create applications with many contracts, but you can draw on some of the open source contracts that exist out there in the ecosystem, be they currency exchanges or identity services or data storage, what have you. In terms of objects, the signatories of the smart contract can modify its terms and which determine how the subjects of the contract interact. So this means that depending on the contract itself, of course, because it's open source, you can create your own version of it or rewrite your own version of it. But for any contract that's already there, you can change the parameters such to the degree that it allows you to get the service as customized to you. And in terms of an environment, these smart contracts depend on a secure cryptographic environment to function safely, ensuring that the data they process is immutable and transparent. So we won't talk as in depth about the kind of back end of how these things are processed. So we'll focus a little bit more on the front end in this lecture. If people are curious about the back end of how the smart contracts are kind of run in the virtual machine, let me know, and we'll kind of potentially put that into our future lectures. Who is using smart contracts? It might seem like a very fringe thing, but in fact, they're one of the main things that are that the whole kind of crypto ecosystem is being built around. And in particular, they're at the heart of decentralized finance. This concept of decentralized finance includes many different things. The most basic level are purely for crypto enthusiasts, interact with other crypto enthusiasts, and to a degree, this includes decentralized exchanges. So that is to say, if you wanted to buy Bitcoin or sell Bitcoin and buy Ethereum or sell Ethereum or buy any other token, you could go through a company that will do this for you, similar to Robinhood, called like Binance, or you could do it in a decentralized way that instead of relying on a particular company to take your money and then give you a token, you will have a smart contract that you just send the tokens to, and it will send you the tokens at a good exchange rate without any company as a middleman. So these are decentralized exchanges. Other lending protocols. So if you wanted to lend your money or borrow money in crypto, then there's ways of kind of locking your money into contracts to get some interest on them, as well as some other synthetic derivatives. As for now, DeFi is still a highly experimental and risky niche within the wider cryptographic space, but it is growing rapidly. And so some smart contracts that are popular DeFi protocols like Compound, which is a company that allows people to earn money on the crypto they save, so kind of earning interest. And similar, Aave is similar, and Uniswap is a decentralized exchange. If you have the PDF, you can click on these links to learn a little bit more about them. And this, I won't kind of dive into the descriptions of these particular decentralized finance applications, but you can kind of read a little bit more about them here or click on the links. In terms of who's using them beyond pure crypto players, we've seen the uptake of smart contracts by many different companies in many different spaces. And I've listed a few here. So Ubisoft, one example of a video game company, is crafting specifically designed smart contracts that allows people to, on their own, own, transfer, and claim rare NFTs that are based on popular on their popular gaming franchise. We'll talk more about NFTs today. The Dutch bank ING has co-created a blockchain-based trade settlement system using smart contracts. And so again, if you're trying to make sure that trades happen and that there's eliminating counterparty risk, so you're eliminating the ability for somebody to take your money and not give you what they promised, then smart contracts are a great way to do that, because you don't have to trust a middleman to make sure that they're actually the goods are going to get delivered. And so a lot of banks, not just this Dutch bank, but a lot of banks, both in Europe and in Singapore and to a degree America, are using crypto and smart contracts for more and more different kind of interbank activities, because there's just a lot of money at risk, and this smooths and automates a lot of the processes that they would be doing by paper or by hand. And beyond that, the governments themselves are starting to step into the space. So the Swedish government is testing applications such as a blockchain-based land registry for approving ownership of land that itself is built on smart contracts. So this starts to allow the possibility for you to buy a house and then sell shares of it onto a liquid, publicly tradable market, but is still kind of backed by the government's guarantee that if you own the token, you really own the house, and vice versa. And so this is something that kind of muddies the waters between the idea that crypto is purely going to be something that's decentralized and gets rid of our dependence on governments, because sometimes having the government step in is something that can actually add a lot of value to the system. But the actual smart contract functionality of it allows that once certain kind of checks are made, let's say by the government, that a lot of automatic kind of trades can take place via tokenization, which we'll talk about going forward. Are there any questions about any of the kind of basic high-level concepts that we've gone through so far? Okay. So again, that's just a very, very high-level concept for smart contracts. We'll be digging into it more and more in the coding parts of our class, and also conceptually after midterm break. Next, we'll discuss this concept of tokenization. So some of this might be reviewed, some of it might be a little bit new information. Crypto tokens, kind of as a definition, are a representation of assets or interests that has been tokenized and exists on a cryptocurrency's blockchain. This is a nice Investopedia little graphic. Some people, by the way, have asked me if there's good resources. I'll start to be compiling kind of PDFs that I'll put online that will accompany the content that I'm putting on here. But in general, Investopedia is a good kind of place to get some summaries of any kind of concepts that you or have doubts about or want to learn more about. So that's one kind of a quick plug for a place to get some additional information. To discuss the idea of what are crypto tokens is this versus a cryptocurrency, which is sometimes just called crypto itself. If you're trading crypto, which one are you really trading? The word crypto typically refers to cryptocurrencies, and crypto tokens or utility tokens or other kinds of tokens refer to, again, tokens. And these are quite similar in some ways and quite different in other ways. So the similarity or the difference, I guess, is cryptocurrencies, they're digital representations of value that are facilitated by blockchain technology, and they're not supposed to do anything else. They're purely supposed to be an asset that somebody will pay money for, and you can transfer this, and it has some kind of value on its own. But it doesn't do anything. Whereas a crypto token is still tradable. It's still something that has value, but it's supposed to do more than just purely be a store of value or a medium of exchange. And so, again, these crypto tokens become digital representations of assets that exist on a blockchain. And these enable investments, storing value, making purchases, raising capital, or doing other things as well. So if you kind of think of, just look at the graphic here, is that if you have money, of course, it's a purely something that you pay to your bank, you pay to your bills with, etc. Tokens are the idea that you create something new that, of course, in this case, in a poker game, let's say you're using to play the game of poker. In order to go into a casino, you need to play with their items. You need to bet the tokens that are part of the casino's game. But of course, you can eventually cash them out into real dollars. In a casino, of course, the tokens are pegged to fixed dollar amounts. But in the crypto world, there might be some varying value of a particular token. But in general, tokens are going to be used within a certain ecosystem to do a certain thing. So again, coins basically oftentimes also use their own blockchain to keep track of data. And so we'll have, there's a plethora of different kind of layer one, as we call them, chains out there. We talked about Bitcoin, we talked about Ethereum, but because the code is open source, there's many, like thousands of different kinds of coin currencies that are out there that don't do anything other than purely allow you to prove that you have them and transmit them to people. Whereas tokens, again, oftentimes use other people's blockchain infrastructure, such as Ethereum, not exclusively, but quite often. They don't need to create a new blockchain or worry about validation themselves. So you're not creating a new layer one, you're not getting miners, you're not necessarily trying to worry about all of those consensus protocols that we talked about at the beginning of the kind of lecture series. But as a consequence of that, they oftentimes will have to pay some kind of rent or fees to the validators of the backbone blockchain that they are working from for the right to use it. So within the Ethereum blockchain, we have this Ethereum network that again both stores the value in the tokens of Ethereum, but also the network itself is validating the transactions of other tokens that are built on top of it. And also validates the kind of truth and veracity of the smart contracts that are kind of built on the Ethereum network. Again, Ethereum is the most common kind of smart contract platform, but other platforms such as Ripple are starting to create their own playgrounds that do very similar things to kind of this support smart contracts on different layer one blockchains. So some of the benefits of tokenization is that we have, again, fewer financial intermediaries. It's not necessarily to put your money to a bank and then buy securities through the bank, and hopefully the bank has, will be able to pick up the phone when you call it if you want to make some purchase. Everything is going to be purely through your wallet and purely through the contracts that you're working with, and they're going to basically always be up, so you can always interact with them. And because of this, you can automate things much more easily. So if there's a smart contract that you're borrowing money from, if certain conditions are met, you want it to, exchange currency right away, you can do this in an instant and set up a whole kind of pipeline to react to whatever signals are in the market to make your trades for you automatically without having to go through any of these financial intermediaries that might have some downtime or might, again, rely on somebody to kind of make a judgment call on their own through a financial advisor or what have you. Everything is going to be purely through this set of interconnected contracts that you can quickly and pretty seamlessly interact with. And again, these can do many things, such as exchanging valuables, such as fiat money for stocks, tokens, or real estate, especially as more tokens become pegged to a kind of real world assets, as we'll talk about over time. The crypto world will start being less kind of an echo chamber and just kind of a spill over into the real world little by little. Some types of tokens, we talked about coins are, again, purely a medium of exchange, and tokens are something else. What are this other thing that they are? There's a few different categories here. The most common kind of umbrella term is utility tokens. So this is going to be used for the payment of services in our decentralized applications. And so, as an example, this idea of utility tokens became popular when people were first starting to try to raise money for different projects. And the idea was that if you could pre-sell some set of, similar to Kickstarter or pre-ordering, if you could buy some of the services or products from a company way before it was actually built, you might be able to get it at a very cheaper price. And then you might not want to consume a ton of that service. But it's similar to buying futures on some commodity. If you're able to get a much better price for, let's say, playing in a casino, then you're able, if any other people want to go use a casino, once the casino is actually built, you can buy for example, the tickets on pennies on the dollar way in advance and then sell them the access to this casino later on. So the idea of utility tokens was used partially as a way to raise money for startups and as a way to speculate on the market and as a way for people to monetize the usage of whatever application they're building. And we'll kind of discuss this a little bit later on as well. Governance tokens are this idea that this allows users to vote on how their app is run. This was another thing that became very popular. There's a lot of theories about how voting or decentralized ownership can be done more effectively, and many different theories of kind of making sure that these people who are collectively owning an application can have their voices heard in an efficient and productive way. Gained a lot of steam, especially because crypto, as an initiation, was against this idea of top-down management. Now, these days, the idea of top-down management is a little bit more acceptable, but still, many applications are still kind of governed in this decentralized way, and tokens are given out as a way to facilitate this and give you votes in the system. The concept of security tokens is something that you should not confuse with the idea of like cryptographic security. These are securities in the sense of that stocks are securities or a bond is a security. These are tokens